Well, I'd like to thank you for inviting me to have a sharing here. Actually, this is the report in 2021. CICC and our research institute spent 3 months. We have this book, Carbon Neutrality Economy. I would like to make some introduction to you and also the latest progress. On the path to the carbon neutrality, petrochemical and the chemical industry are playing a very important role. There are two aspects. One is the carbon emission for that chemical industry is quite significant. For example, in the 10 billion tons of the emission, 10% is from chemical industry. Also, the chemical industry is also a very important solution for the carbon neutrality. Chemical industry is a very effective approach for the carbon neutrality. You see that this is a distribution. And for the chemical industry, it's very difficult to achieve carbon neutrality. There are a couple of factors. In the chemical production process, you need a steam at a high temperature. Of course, there will be emission. And then there are a lot of chemical reactions. It generates CO2. These large contributors for the emission are the synthetic ammonia, methanol, olefin. These 7 to 8 segments accounts for 70% of the carbon emission in the chemical industry. So there are a couple of focuses on these industries to reduce the carbon emission. Another is we have done a calculation based on the technology level. If we want to reduce the CO2 in these key sectors, and then there will be green premium. For example, the normal cost is 1, then you have a green production. What is this multiple will be? What is the premium will be? If you have a carbon capture or storage, the premium is 60%, and it's not very high. If in the ammonia or the methanol, if you use the green hydrogen, and then the production cost will be 200 or 300 compared with current technology. For example, in EU, they want the green technology, and they want to have electrolysis for the hydrogen, or PV. They also want electrolysis of hydrogen. Also, they want a bio-based the material, so that the production of methanol cost will be 6,700. And if you use, you can see that the premium is really higher. And if we compare with the coal and natural gas, therefore, this green transition, the cost will be very high. So here, this is about CO2 capture and storage. This impact will be significant. However, generally speaking, its cost is still controllable. In the carbon neutrality process, so what kind of contribution can be from the chemical industry? The first contribution is the carbon capture and the sequestration. For example, like steel industry or the cement production or the chemical production. The CO2 emission is unavoidable, like cement production. The CO2 emission is 1.4 billion tons. Then the whole China and the emission, that would be 10%. So in this process, there will be unavoidable emission. Even with technology improvement, for example, if we want to achieve carbon neutrality in 2050 or 2060, you have to store these CO2 emission, or you have offsetting. And I think that the most feasible way is carbon sequestration. In this green transition, the green power is really faster than the solar power and the wind power. And also, like lithium battery storage is faster than CCS, carbon capture and sequestration. Namely, in this low carbon process. For example, like a power battery, in 2010, the energy density is 100 watt-hour per kilo, but now it's 300 watt-hour per kilo. That's 3 times increase. From the price, you can see in 2010, the single watt-hour lithium battery is 4 yuan, but now it's only 0.5 yuan. So in just 14 years, there is a 30-fold efficiency improvement. This is really significant, great improvement. But for the CCS, they are still relying on the chemical absorption, like ethanolamine or the ammonia solution for the absorption. So that this energy consumption for the carbon capture is 2.4, 2.5, but now is further reduced to 2.2 and 2.3, only very small improvement. For example, 2.4, 2.5 G joule. For the 1 ton CO2, you need 80 kilogram, 90 kilogram standard coal for the absorption. I think that the technology is mature. However, the reaction mechanism, the absorption mechanism has not fundamentally changed. So CCS technology improvement is not significant. And currently, the way in China is capture the CO2 to drive the gasoline, drive the crude oil, or have a food grade CO2. These are mainstream way for the utilization of CO2. And I believe that we lack of the million-ton scale large level CO2 sequestration plant. You put it underground and to store it in the aquifer, saline aquifer. You need to have wait for 100 years. We do not have time to do the test. I think that one urgency is we must start now. This is the first. And secondly, about carbon biomass material alternative, I think that this synthetic biochemistry and we believe that these bio-based material cannot be the mainstream material. Like industry is supplying a lot of raw material. For example, you collect this biomass to the plant to produce it. Also, currently we have a fiber, semi-high fiber or the lignin, and we crush it and to convert it into CO2 or sugar. It's quite difficult. It's really difficult to connect it with the daily consumption. For example, make it clothes, make it cosmetic, or daily consumption. Will our consumers buy it? It's really difficult. And also to make it an industry product is still quite difficult. And thirdly, another very key is the chemical production need large of the steam and the heat. In this process, a key technology is the electricity. How to, for example, we have the electricity to address the heat and the steam issue, and this will be a very good contribution to the reduction of carbon emission. And also, last one, I just want to mention that people are focusing on the chemical industry's contribution to CO2 emission. However, for the global greenhouse gas emission is not only from one gas, only from CO2. There are other gases. For example, I will mention one product. For this product consumption in China, totally they only 700,000 tons per year, but the greenhouse gas impact is equivalent to 1.4 billion tons of CO2, namely the 800,000 tons of this particular product is equivalent to 1.4 billion tons of carbon emission. But in that regard, the technology progress is very slow. This product, what this product is, it's like a refrigerant or coolant in your air conditioner. So their greenhouse, the impact is really huge. Also, like this, the automobile, the coolant, this is a greenhouse impact is almost zero. If we promote this product, this will be more effective than directly cut carbon emission, because and basically you stop this air conditioner coolant, there will be more contribution to the carbon emission. So we need to have an overall comprehensive consideration. Another is we have the estimation on the chemical industry's carbon emission reduction. So you can see this is our past estimate, but now there will be some change. Now from now to 2030, the wind power proportion will be higher. And why? In 2021, there is energy control and carbon emission control. They have a lot of restriction on the chemical industry. Then 2022, there is a relax. Therefore, in the future couple of years, there will be a lot of heavy chemical industry products to be invested. And this is one. And also another one, I believe that is the 2026. The EU will impose the border carbon tariff to Chinese products. Previously we heard that in China the carbon tax is 100 yuan. In Europe that's 100 euro. So actually CO2 CCS, and we believe that the minimal carbon tax 400 yuan is minimal. If you only refer to the current domestic price, it's very difficult to make any change, and we must refer to European price to drive the action. So by 2026, there will be the more enhanced restraints on the carbon, and one is favorable, another is unfavorable. This is a curve. Maybe first it will go up, and then will go down. Thank you very much. Thank you.